Automation, safety, emissions, and measurement technology are all closely connected. I'm Tory from Fresenius, and behind me is a recycling plant, an industry where all of this is coming together. Let's take a closer look. So, welcome to my presentation on how measurement technology from Fresenius can improve process efficiency and make automation possible. Right now, everyone is talking about AI. But AI is only as good as the data behind it. High-quality real-time process data is the foundation for smarter automation, reliable decision-making, and truly intelligent process control. In the next few minutes, I will show how in-process measurement increases control, improves efficiency, and enables automation. And to make that tangible, we will start with a practical example: oxygen measurement in recycling processes. In aerosol can recycling processes, for example, oxygen measurement helps control inerting efficiently. The real challenge is not just shredding the material, it is controlling the gas atmosphere during the process. As soon as cans are opened or crushed, flammable gases can be released. That is why oxygen concentration has to be reduced by adding nitrogen. This process is called inerting. To run that process efficiently, you need live oxygen measurement. In this example, nitrogen is added until the measured oxygen value reaches the target range of around 4 volume%. Without live oxygen measurement, you might keep feeding nitrogen continuously without knowing the actual oxygen level. But with live measurement, you know the actual oxygen value immediately. That means you use nitrogen only when it is really needed, and only in the amount the process actually requires. And because you can see when oxygen is back in the target range, you can also run the process faster. So, this is not just about safety. It is about controlling inerting efficiently. This diagram shows an example of a shredding process. In some systems, aerosol cans are crushed, while in others, the waste is shredded. In both cases, when the process is inerted, extractive oxygen measurement is needed at least 2 measuring points to ensure that oxygen levels stay low enough. One point is at the top of the shredder and the other at the bottom, since oxygen concentrations can vary between these areas. Our analyzers can be configured for any relevant measuring point in the process. To define the right solution, you simply indicate your measuring points in the technical information form, and our experts will take care of the technical analyzer design. To get the form, contact us or chat with me on our website, freseniusinstruments.com. In the UK, for example, aerosol treatment guidance describes a controlled inert atmosphere using nitrogen injection and gas extraction, and it links plant operation directly to oxygen levels. If the inerting system fails or oxygen levels become too high, the treatment process should stop automatically. The UK HSE also states that inerting design requires continuous monitoring of oxygen and flammable gas or vapor concentrations. So in many processes, oxygen can be a safety signal and a process signal. If flammable gases are present in the process, keeping oxygen levels low helps reduce the risk of ignition and explosion. In other processes, the goal may be the opposite, where oxygen has to be maintained within a defined range to keep the process stable and efficient. That means oxygen measurement is a real-time signal for controlling the process. And with that, let me show you our analyzer technology enabling this on the next slide. The Fresenius GA21002 offers paramagnetic oxygen measurement for demanding recycling and process gas applications. It delivers stable, continuous analysis with a 1-second update interval, minimal offset drift, and measurement that is free from cross-sensitivities. That means you get a fast, reliable oxygen signal you can actually use to control the process in real time. No waiting, no guesswork, and no unnecessary compromise when the oxygen value matters for safety and efficiency. It is designed for long-term stability and for harsh gas mixtures in real industrial environments. Oh, I might be in the way here. Let me just quickly move to the other side of the slide. So, the last feature is especially unique in our paramagnetic sensor technology. Because we developed a completely new paramagnetic measuring principle, our sensor is vibration insensitive. Traditional paramagnetic sensors often rely on a suspended measuring element that can react to movement and vibration. Our sensor does not use that kind of swinging element, and that makes a real difference in industrial use. It means a highly stable oxygen signal, no distortion caused by vibration, and a sensor that is exceptionally well suited for demanding process conditions. Paramagnetic oxygen measurement excels in harsh recycling atmospheres, especially with flammable mixtures and aggressive gases. It avoids laser-based setups, reducing complexity and making export possible in restricted regions. Unlike zirconia, it's ideal for flammable, organic, and toxic gases. With no consumable sensor, it ensures long-term use and predictable maintenance, making it robust for continuous industrial operation. Another strong example of gas monitoring and recycling is the continuous monitoring of fluorocarbon emissions. This is especially relevant in refrigerator recycling, where compliance depends on the controlled handling of gases from both refrigeration circuits and insulating foams. That is exactly where continuous gas analysis becomes valuable. Using the NDIR principle, we can monitor exhaust streams continuously to improve emission control, process transparency, and regulatory compliance. This approach is well suited for recovery lines, separation stages, and exhaust streams, and it can cover typical gases found in refrigeration recycling, such as R11, R12, R34A, and R141B. This brings us from emission monitoring to automation. A good example is our Smart Control 300 in refrigerator recycling. Here, the system can identify the gas inside a refrigerator immediately after extraction. That result can then be used directly for an automated decision. For example, the refrigerator can be assigned to the correct recycling line, depending on which gas has been detected. And that is exactly where process automation becomes powerful. You get a fast, reliable result with no unnecessary delay, which makes the recycling process as quick as possible. Of course, the same principle can also be applied to other sorting systems, where the gas composition is the basis for automated decisions. Talk to us for individual solutions. Let me conclude this presentation. Today, I wanted to give you a few practical examples from recycling. And what they show is that with Fresenius, you get the full package. From reliable emission monitoring, to fast automated safety control, to automated decision-making based on real-time gas analysis, we cover it all. Use our quick and reliable gas measurement solutions to make your processes safer, faster, and more efficient. If you would like to learn more, contact us today or chat with me directly on our website. Thank you for your attention.